Hello students, welcome to class 11 physics. In this video we are going to discuss about the topic Newton's third law of motion of chapter 5 laws of motion. Write and explain Newton's third law of motion. During interaction between two, whatever amount of force is applied by first object on second object, similar forces applied by second object on the first object. Direction of these forces is in opposite direction. Or you can write it as action and reaction are force of equal magnitude but act in opposite direction. That normally we say action and reaction are always equal and opposite. So if we consider two objects, object A and object B, then the force applied by A on B is equal to the force applied by B on A. Both are in opposite direction. So one is considered as the action and the other is considered as the reaction. When ball A hits ball B, then by collision the ball B will be applying force on A, but now it will be in the opposite direction. Here any one force can be taking action force and another force as force of reaction. From these laws, it is clear that an isolated force do not exist. Forces are always in pair. As we had seen that if we take the object, suppose a book is there on the table, then and it is stationary, that does not mean that force is not acting on it. There are the force of pair which balances it, because by default the gravitational force will be acting on the book in the downward direction. At the same time the normal force is applied on the book in the upward direction. So there is a force of pair, right, due to which the book is stationary and they are in opposite direction. But these forces act on different object and in mutually opposite direction. Example, when a spring is compressed, it is compressed due to force applied by hand. Compressed spring provides the restoring force on hand which can be experienced on the hand. So we are having this another example. Suppose there is a spring, then with the help of the hand the force is applied on the spring and the spring gets compressed. It is in the downward direction. Then at the same time the compressed spring applies force on the hand due to its restoring force. This is called as the restoring force of the spring, which is applied on the upward direction to the hand. So both these forces are in the opposite direction and they are equal. So this is the Newton's third law of motion, where two forces will be equal in magnitude and opposite in direction. Such type of forces are called as action and reaction. So action and reaction are always equal and opposite. So students, you may note down this theory. Write important points of Newton's third law of motion. In these law, action and reaction both are force, which indicate that forces are always in pair. Because two forces are applied on the object, we can say that these are the forces in pair. Force applied by B on A is equal to force applied by A on B, but in opposite direction. Second, isolated force do not exist because forces are always in pair. The example that we had already discussed, because the book is stationary, that does not mean that force is not acting on that, but the forces that is acting on the book which is stationary, it is in pair. So isolated force do not exist, but there are forces always in pair. Third, action and reaction force are equal in magnitude but act on different object. Thus, action is cause and reaction is effect. So, as we had already said that if we take a ball A, right, and if it hits ball B, then the ball will be applying force on A but in the opposite direction. So the ball B comes in motion because of ball A, because the force is applied by A on B. So the force applied by A on B, that is action, and in reaction the ball B applies force on A. So action is cause and reaction is effect. Fourth, action and reaction are force which act on different object. Let A and B are object of given pair. Then by Newton's third law of motion we can write FAB equals to minus FBA. That means force applied on A due to B is equals to minus force applied on B due to A. When we consider motion of any one object A and B, then we have to consider force on one object only. It is not correct to consider resultant force as 0. When we consider system of two particles A and B, then FAB equals to FBA are internal forces of the system A and B. Resultant of internal forces is 0. Hence we can use Newton's second law for system of particles also. That means if we consider the forces of A on B or forces on B from A, and if these two objects are considered as a system of particles, then these two forces are the internal forces and the resultant of these internal forces is 0. So we can use the Newton's second law for the system of particles also. So students, you may note down these points for Newton's third law of motion.